Hello there. We're going to solve problem 10.23 from the Caliper book. It reads like this. From the plot of yield strength versus grain diameter raised to minus 1 by 2 for a 70% copper, 30% zinc cartridge brass, figure 10.15, determine the values of the constants sigma 0 and ky in equation. They've given equation number as 10.10. It's actually equation number 10.7 and I have corrected it in the pencil. So the concern figure here, please note, is 10.15 and the equation is 10.7. So I have marked the page and I'm going to flip it, and therefore we have, as you can see, the equation here is 10.7. So for 10.7 equation, this is the Hall-Petch equation. It's an equation which relates the grain size to the strength of the material, and the figure that we have to refer, that figure is here. This is figure, as you can see, 10.15, and it is for a 70% copper, 30% zinc brass. So what we're going to do here is, as you can see, on the y-axis they have mentioned the yield strength of the material in megapascal, and on the x-axis here they have mentioned the grain size in terms of d raised to minus half, that is 1 by square root d. They are also mentioned grain size in millimeters dimension. So I'm going to pick here two values from this graph. So for example, if we take 4 and I align this set square such that we get a 90-degree line to the axis out there. So I mark this point here and this point, as you can see, when I refer to the total distance from 1 to this is 13 mm. So we say for a distance of 13 mm on the graph, the difference in the yield strength here, as you can see, is 50, right? And we are interested in, this is 50 megapascal, and we are actually interested in this distance. So for example, this is going to be about approximately 6.5, right? So for 6.5, not much calculation required here. 6.5 mm, you'll get obviously a difference of 25 megapascal. So the value here can be considered as 75 megapascals. Now in a similar manner, I'm going to take another point, 12 mm, and when I drop a perpendicular, as you can see, that will work out to this point, which is 175. So in the given equation, if we try to plot the values, as you can see, we have, if we try to tabulate the values, we have for a grain size raised to minus 1 by 2, that is also, as I mentioned, 1 upon square root d, expressed in millimeter raised to minus 1 by 2. The sigma y here expressed in megapascal, we found two values. For 4 we found it to be 75, and for 12 we found it to be 175. Now that gives us two equations. We talk about this particular equation. This is a Hall-Petch equation. Sigma y is equal to sigma 0 plus ky d raised to minus 1 by 2, and we have the values of d raised to minus 1 by 2 and sigma 0. These are the values, sorry, sigma y, these are the values that we already have. So what you want to do is have two equations formed. So two equations that we can form using equation 10.7 is sigma 0 plus 4 ky is equal to 75. So I'm writing the value of 4 here and 75 here, and the other equation is sigma 0 plus 12 ky is equal to 175. So this is equation 1 and this is equation 2. So when we make use of a calculator in order to solve the problem, here for example I am choosing the equation mode and the number of unknowns selecting as 2. It asks me for the value of a1. This is sigma 0 and the coefficient of this is 1. Then the coefficient of b1, this is 4, is given. Then we have the coefficient of this value, that is the constant, that is 75, that is equation 1. And then in equation 2 we have this value as again 1, and then ky coefficient is 12. So we put b2 as 12 and c2 is going to be 175, and then when we press equal we get a value of x as 25 and y as 12.5. So we have here ky and sigma. The value of ky here is 12.5 megapascal millimeter raised to half, and the value of sigma 0 here is equal to 25 megapascal that we have found out. So the given equation 10.7 can be rewritten with the values of the constant seen here. So this is the equation. As you can see, the equation is here. We have that equation and we have found out the value of sigma 0 and ky. Sigma 0 and ky here. When you substitute the values of sigma 0 and ky, we get an equation which can be written as sigma y is equal to 25 plus 12.5 d raised to minus 1 by 2. This is the Hall-Petch equation for 70 Cu30 zinc brass. Thank you.